Yo, what's up guys? Today we're going to be looking at the converse of the isosceles triangle conjecture. I know, it sounds tricky, but we'll get through it, don't worry. The conjecture states that if the base angles on a triangle are congruent, then the legs are congruent as well. Here we see a triangle with congruent base angles. This fact is given to us. But in order to get our proof going, we'll have to fill in some other pieces of the puzzle. These angles on the top are congruent because of the postulate that says every angle has only one bisector. This bisector bisects it and, that sort of thing, meaning it splits into two equal angles. So now that we've figured that out, and we already know that the base angles are congruent, we only need one more piece or part of congruency to continue our proof. So looking at the triangle, this line running down the middle, line segment CD, this line segment is congruent to itself. We know this because of the reflexive property and because it's the same line in both triangles, so it's gonna have to be congruent. So now we have enough pieces to say that these triangles are congruent to each other. I can freely say this because of the ASA triangle congruence conjecture. This takes the angle, the side, and the other angle that we've proved are congruent to the same parts on the other triangle. And it basically says that this is enough to prove that they are congruent to each other. So now that we know that the triangles are congruent, we can use CPCTC, also known as the corresponding parts of congruent triangles conjecture, to fill everything in. With us filling everything in, we know that the legs of the triangle have to be congruent, therefore making this triangle isosceles and proving the converse of the isosceles triangle conjecture to be true. Thanks for watching. That was a fun one to make. Have a good day, you guys. See ya.